Until this point, we have analyzed rudimentary legislative choice settings, settings where a single decision-making body makes decisions using simple majority rule. The spatial model, however, can help us understand more complex legislative choice settings, settings that better model real-world legislatures. This video will introduce several complications to the simple one-dimensional spatial model to account for real-life features of the U.S. Congress. Specifically, we will use the spatial model to analyze the filibuster in the Senate, which requires a 3/5 supermajority to advance some alternative policy against the status quo, and the presidential veto, which requires a 2/3 supermajority to override and advance an alternative policy. We will use the spatial model to understand how these two legislative procedures result in outcomes that actually diverge from the median voter theorem. Although this theory, which we call pivotal politics, was developed to explain the U.S. Congress, the insights we gain from working through it can be applied to any arbitrary collective choice setting. In the rudimentary legislative choice setting that gave us the median voter theorem, policymaking happens in just two stages. First, a bill revising some status quo policy is introduced, or no bill is introduced at all. Second, if a bill was introduced, legislators vote between the bill and the status quo. The actual lawmaking process in the U.S. Congress and legislatures worldwide is a bit more complicated. The first step, however, is the same. A bill is introduced or not. We'll assume throughout that bills are introduced by the median legislator, labeled M. If the median doesn't introduce a bill, then the legislature retains the status quo. If they do introduce a bill, then we move to the next stage. The second step takes place in the U.S. Senate. Rules of the Senate allow any individual senator to filibuster a bill, that is, to delay it indefinitely, effectively killing the bill. However, a 3/5 supermajority of senators can end a filibuster and move the bill to the next stage. If there's a successful filibuster, then the legislature retains the status quo. The new bill does not pass. If 3/5 of senators choose to end a filibuster, or no senator initiated a filibuster in the first place, then the bill passes both chambers and we move to the next step. The third step takes place in the White House, on the president's desk. When a bill passes both chambers, the U.S. Constitution authorizes the president to choose between signing the bill, in which case the policy passed by Congress revising the status quo is enacted, or vetoing the bill, nullifying it, and we move to the next stage. The fourth and final step takes place back in Congress. If a bill is vetoed by the president, a 2/3 supermajority of legislators in both chambers can override the veto. If Congress fails to attain the 2/3 supermajority necessary to override the veto, then the veto is sustained and the status quo prevails. If, however, 2/3 of legislators choose to override the veto, then the bill passes and the new policy revising the status quo is enacted. If we know the location of a status quo policy, and we know the spatial preferences of all the legislators, then we can go step by step through the lawmaking process through this flowchart and determine the equilibrium outcome for any given status quo. Let's start with the first step. Throughout the video, we'll use this model legislature with 11 legislators labeled L1 through L11. The first step is equivalent to the rudimentary legislative choice setting. The median legislator can propose a bill revising any status quo policy, such as the three labeled here, to its own ideal point. If a status quo is already at the median's ideal point, they don't need to introduce a bill. Let's suppose the median introduced bills to revise each of the three status quos to their ideal point and sent them to the Senate. Will they pass? In the next step, senators decide whether to filibuster the bill or not. In the U.S. Senate, a 3/5 supermajority can end a filibuster to pass a bill. How do we determine which policies a supermajority of legislators prefers to a status quo? In the case of simple majority rule, we just had to look at the median. But now we have to consider supermajorities rather than just simple ones. In our 11-person legislature, a 3/5 majority is 7 legislators. 3/5 of 11 is 6.6, but we can't have fractions of legislators, fractions of people, so we round up to 7. So we have to determine the set of policies that 7 legislators prefer to any given status quo. To do so, let's start by drawing in every possible 7-person supermajority. Because legislators vote for the policy closest to them in space, coalitions of legislators who vote the same have to be continuous. There will never be a case, for example, where L1 and L3 vote one way, but L2 votes a different way. Each of these blue lines represents a possible 3/5 supermajority coalition. Notice that all of them contain legislators 5, 6, and 7. Since every possible 3/5 supermajority coalition contains these legislators, we really only have to consider them when determining whether a 3/5 supermajority will vote to revise the status quo. And again, since coalitions have to be continuous, We know that if legislator 5 and legislator 7 agree on a policy, then legislator 6 does as well. So we really only have to consider two of them, legislator 5 and legislator 7. We'll label them F sub L and F sub R for the leftmost filibuster pivot and the rightmost filibuster pivot. We call them pivots because these legislators are ultimately pivotal in whether a bill passes or the status quo is retained. So to determine the set of policies that can beat the status quo, we need to determine the set of policies that both the left filibuster and the right filibuster prefer to the status quo. Let's start with SQ3. We'll do exactly the same process that we've done in previous videos and construct each pivot's preferred to set to the status quo. That is, the set of policies closer in space to the pivot than the status quo is. The overlap of the two pivots' preferred to sets will be the range of policies that both pivots prefer and therefore represent that 3/5 supermajority necessary to advance the bill. In other words, the overlap of the two pivots' preferred to sets is the win set against the status quo. Now we can compare the median's ideal point, the point they would introduce if there were no filibuster, to the win set, or the overlap of the two pivots' preferred to sets. Here we can see that the median's ideal point M is in the win set, so the median can propose exactly its own ideal point, and the Senate will pass it without a successful filibuster. Now let's look at SQ1. First, we'll draw in the preferred to sets for the two filibuster pivots. For SQ1, we can see that the median's ideal point is not in the win set. It's not in the overlap of the two filibuster pivots' preferred to sets. So, if the median were to propose its own ideal point, the left senators would mount a filibuster, and the right senators would not be able to get the 7 legislators necessary to end the filibuster, because L5, that filibuster pivot, prefers the status quo, and their vote is necessary to end the filibuster and advance the bill. So, should the median give up and not introduce a bill at all? No. The median can still make itself better off. The win set, after all, is not empty. The median could propose a bill just at the rightmost edge of the left filibuster pivot's preferred to set. Since that bill is in both filibuster pivots' preferred to sets, it's in the win set, they will both vote to advance the bill. So the median can't get exactly their ideal point, but they can still move policy toward their ideal point. Finally, let's look at SQ2. Again, we'll draw the preferred to sets for the two filibuster pivots. In this example, we can see that the median's ideal point again is not in the win set, like with SQ1. In fact, the win set is empty. There's no overlap whatsoever between the two filibuster pivots' preferred to sets. Because the status quo is between the two filibuster pivots' ideal points, they will never agree to any policy revising it. Any attempt to move the policy rightward will result in a successful filibuster from the left, and any attempt to move the policy leftward will result in a successful filibuster from the right. So, the legislature will retain SQ2. There's no policy the median can offer that both makes itself better off and can survive a filibuster. In this step, we've seen how non-median policies can be equilibria when supermajorities are required to revise a status quo. Any policy that's between the two filibuster pivots is in equilibrium, is stuck, because the pivots will never agree on a new policy. The win set for those status quo policies is always empty. Similarly, status quo policies that are near one of the filibuster pivots have very small win sets that might not include the median legislator's ideal point. In those cases, the median can move policy toward their ideal point, but policy won't fully converge to their ideal point. The median voter theorem, in other words, does not hold when using supermajority rule. On to the next step. In the next step, the president decides whether to sign a bill or veto it. To simplify our analysis of the presidential veto, let's assume for now that the filibuster isn't an option, and just consider whether, using simple majority rule, the median can move policy to its own ideal point. Let's assume we have a right-leaning president with an ideal point between legislators 10 and 11. To determine whether the president will veto a bill, we need to find the president's preferred to set against each status quo. Let's start with SQ1. SQ1 is quite far from the president's ideal point, and therefore their preferred to set is very large. The median legislator's ideal point is in the president's preferred to set, so the median can pass a bill exactly at its own ideal point, and the president will sign it, and it will replace the status quo. Next, let's look at SQ2. SQ2 is a bit closer to the president's ideal point, so their preferred to set is a bit smaller. However, SQ2 is on the same side of the median legislator's ideal point as the president's. So the median only wants to move SQ in the direction opposite the president's ideal point. As a result, the median legislator's ideal point is not in the president's preferred to set, and a bill that moves the status quo to the median's ideal point will be vetoed. The median wants to move policy left, and the president wants to move it right. They will never agree. So SQ2 will be retained. Finally, let's look at SQ3. SQ3 is very close to the president's ideal point, so their preferred to set is quite small. Unlike SQ2, SQ3 is on the same side of the median's legislator's ideal point as the president's. However, the median's ideal point is not in the president's preferred to set. Should they give up? No. There are still policies in the president's preferred to set that are closer to the median legislator's ideal point. In other words, there are policies that make both the median and the president better off. The median could propose a bill just at the leftmost edge of the president's preferred to set. Since that bill is in the president's preferred to set, they'll sign the bill. So the median can't get exactly their ideal point, but they can still move policy toward their ideal point. In this step, we've seen how non-median policies can be equilibria when the president has the power to veto bills. Any policy between the median legislator's ideal point and the president's ideal point is in equilibrium because the median wants to move policy one direction while the president wants to move it in the opposite, so they'll never agree. Similarly, status quo policies that are near the president's ideal point but on the same side as both politicians' ideal points have small win sets that might not include the median legislator's ideal point. In those cases, the median can move policy toward their ideal point, but policy won't fully converge to their ideal point. But our task doesn't stop here. The US Constitution allows 2/3 supermajorities of each chamber to override a presidential veto, which brings us to our next and final step. In this step, legislators decide whether to override or sustain a presidential veto. In our 11-person legislature, a 2/3 supermajority is 8 legislators. 2/3 of 11 is 7 1/3, but we can't have fractions of legislators, so we round up to 8. Like with the filibuster example, we can determine the set of policies that can beat a status quo using 2/3 supermajority rule by looking at all possible 8-person coalitions. Each of these blue lines represents a possible 2/3 supermajority coalition. All of them contain legislators 4, 5, 6, 7, and 8. Since every possible 2/3 supermajority coalition contains these legislators, we only have to consider them when determining whether a 2/3 supermajority will vote to revise a status quo by overriding a presidential veto. And again, since coalitions have to be continuous, we know that if legislators 4 and 8 agree on a policy, then legislators 5, 6, and 7 do as well, so we really only have to consider legislators 4 and 8. Let's label them V sub L and V sub R for the leftmost veto pivot and rightmost veto pivot. So to determine the set of policies that can beat the status quo, we only need to determine the set of policies that, if the president chooses to veto a bill, both V sub L and V sub R prefer to the status quo. Now we can compare the median's ideal point to the win set against each of our status quos, the overlap of the two veto pivots preferred to sets to each of those status quos. From before, we know that if the median proposes its own ideal point to replace SQ1, the president will sign the bill, so we don't need to worry about the veto pivots in that case. So let's move to SQ2. Recall from before that the president would veto any policy the median proposes that would move SQ toward the median's ideal point, because that would mean a policy loss for the president. Let's see if the veto pivots will sustain or override that veto. We'll draw the preferred to sets for the two veto pivots. We see that for SQ2, the win set is empty. There's no overlap whatsoever between the two veto pivots' preferred to sets. Because the status quo is between the two veto pivots' ideal points, they'll never agree to a policy revising it. Any attempt to move the policy rightward will result in left legislators sustaining the veto, and any attempt to move the policy leftward will result in the right legislators sustaining the veto. So the legislature will retain SQ2. There is no policy the median can offer that makes it better off and can survive a presidential veto. Finally, let's look at SQ3. Recall from before that the median could move policy very slightly toward its own ideal point when revising SQ3. How does the possibility of a veto override affect how close the median can move policy to its own ideal point? When we draw in the two veto pivots preferred to sets, we see that the win set is quite large and actually contains the median's ideal point. So even though the president would veto a bill that was exactly at the median's ideal point, the two veto pivots and the 2/3 supermajority that they bring with them will override the president's veto, and the median can move policy exactly to its own ideal point. In general, we can see that the president will not veto any attempt to move policy that's to the left of the median. the president is made better off by those status quos converging to the median's ideal point, moving to the right. On the other hand, the president will veto any attempt to move policy that's on the right of the median to the left. The president is made worse off by those status quos converging to the median's ideal point. Because the president will only veto policies that move leftward, and the leftmost veto pivot wants leftward movement, they will always vote to override the president's veto. Therefore, the relevant constraint is just the rightmost veto pivot. As a result, we can ignore the leftmost veto pivot and simplify our analysis. We've now fully modeled each step of the lawmaking process, from bill introduction to bill passage. Along the way, we identified the relevant pivotal legislators, so we don't have to go legislator by legislator and see how they would vote between every possible status quo and proposed bill. We only need to consider the relevant pivots. And we can simplify it further. The right filibuster pivot lies between the veto pivot and the left filibuster pivot. Because coalitions have to be continuous, we know that if the left filibuster and the veto pivot agree, then the rightmost filibuster pivot does too. As a result, we can ignore the right filibuster pivot. We only need to consider one filibuster pivot, one median legislator, one veto pivot, and the president. Our 11-person legislature suddenly becomes much easier to analyze, and these 4 pivots generalize up to an arbitrarily large legislature. The 535-person U.S. Congress, for example, can be analyzed by only knowing the location of these 4 pivots. So we've now seen how supermajoritarian procedures can affect lawmaking, and we saw how this model legislature processed 3 specific status quo policies. Now, we can generalize the theory to describe the equilibrium outcome for every possible status quo policy. Let's now let this horizontal line represent the full range of possible status quo policies. This vertical line I'm drawing will represent the equilibrium outcome for the status quo at that same point on the horizontal line after it's processed through the lawmaking process. To start, let's consider a status quo policy at the extreme left of the ideological spectrum. We can draw in the preferred 2 sets for the relevant pivots and see what policies beat it. The win set here is the overlap between the veto and the filibuster pivots. Any policy that can survive both the filibuster and a veto can beat the status quo. As a benchmark to compare our outcomes to the median voter theorem, I'll draw in this blue dotted line, representing where a status quo policy would converge if it converged to the median legislator's ideal point. For the extreme left status quo policy, we can see that the median legislator's ideal point is in the win set. Therefore, the median legislator's ideal point will be the equilibrium outcome. This status quo will converge to the median legislator's ideal point, represented by this red dot. Now we can slide the status quo policy to the right and see what the outcome is for each point along the horizontal line. As the status quo moves to the right, we can see the preferred 2 sets for all the pivots get smaller, but that the median legislator's ideal point remains in the win set, so policy converges to the median. Once we reach this point, however, the median legislator's ideal point leaves the win set. The filibuster pivot no longer finds the median legislator's ideal point better than the status quo. We'll add this vertical line to denote that we've entered a new region. As we continue to move right, although the median's ideal point is no longer in the win set is not empty. There are still policies that both the filibuster pivot and the veto pivot prefer to the status quo and that are closer to the median's ideal point. All the status quo points in this region will not fully converge to the median's ideal point, but they will move in the direction of the median, as far as the filibuster pivot will allow. Once we reach the filibuster pivot's ideal point, the win set is empty. It's empty because now the filibuster pivot only wants leftward movement, whereas the veto pivot only wants rightward movement. Again, we'll add a vertical line to denote that we've entered a new region. As we continue to move rightward, the win set remains empty, and status quos cannot be changed at all. Any bill introduced by the median will fail, either at the filibuster or veto override stage, so the status quo remains fixed. Once we reach the veto pivot's ideal point, the win set is no longer empty. Status quo policies are far enough to the right that both the veto and filibuster pivot want to move policy leftward. We'll add another vertical line. As we continue to move rightward, we now have a region that's symmetrical to the second region. The win set is not empty, but it does not contain the median legislator's ideal point. Status quo policies will not converge fully to the median legislator's ideal point, but will converge partially, as far as the veto pivot will allow. Finally, we reach a point where the median legislator's ideal point re-enters the win set, and we get full median convergence like we did in the first region. The completed line shows a mapping of all possible status quo policies to all equilibrium policies. Unlike the simple majority rule case, outcomes do not always converge to the median legislator's ideal point. Instead, all status quo policies converge to some point between the veto and filibuster pivot's ideal points. Regions 1 and 5 represent the most extreme status quo policies. In those regions, the win set includes the median legislator's ideal point, so status quo policies converge fully to the median. All the pivots think the status quo is so extreme that the median's ideal point is better. Regions 2 and 4 represent less extreme status quo policies, but still ones sufficiently distant from all the pivots that partial convergence to the median is possible. Pivots still think the status quo is too extreme, but not so extreme that convergence to the median is better. Finally, Region 3 represents moderate status quos that lie between the pivots and therefore cannot be changed at all. Any status quo policy in this region is already in equilibrium, so the slope of the line describing the relationship between status quos and outcomes is exactly 1. The status quo equals the outcome. Even though a majority of legislators may want to change the status quo, they can't because of either a filibuster or a veto. Status quo policies in this region are gridlocked, and we call this region of gridlock the gridlock interval. Every possible status quo policy will converge to some point in the gridlock interval, so sometimes non-median outcomes are equilibria. A benefit of the pivotal politics model is that we can begin to think about policymaking sequentially. What happens to a policy when an election brings in new politicians, and we get a new filibuster and new veto pivot, a new median legislator, and a new president? We can represent any given legislative session with these 5 regions. The boundaries of each are determined by the positions of the pivots. Let's suppose this legislative session is the first ever, and it inherits a series of status quo policies that span the entire ideological spectrum, represented by this line. You could think of this as the first meeting of a legislature after a series of smaller states consolidate, like after the United States became independent of the United Kingdom, or after the European Union formed its European Parliament. Each of the smaller states may have had their own laws and policies that now the larger legislature must bargain and compromise over. You could also think of it more theoretically, as a sort of Hobbesian state of nature where each person or household has its own set of rules, but have decided to form a political community and have to determine a uniform set of rules to which they'll all be bound. Or you could think of it purely in the abstract as a series of objects that will feed through a function and analyze the output. Regardless of how you choose to interpret this uniform range of status quo policies, we can map each to an equilibrium outcome after the legislature considers each for revision. Starting from the left, these relatively extreme policies in Region 1 will converge fully to the median. These in Region 2 will partially converge to the median because of the filibuster pivot. These in Region 3, the gridlock interval, will not change at all on account of the veto and filibuster pivots. These in Region 4 will partially converge to the median because of the veto pivot. And finally, these extreme policies in Region 5 will converge fully to the median. This legislature passed 9 new laws. The 3 moderate status quos remained unchanged, but the other 9 were changed through the lawmaking process. Now, all status quo policies are somewhere in the gridlock interval, in Region 3. Let's suppose an election is held and a new legislature is seated. We now have a president to the left and a veto pivot that is extremely to the left. The median and filibuster pivots have also shifted left. We can think of this as a sort of wave election where the former right-wing government is ousted for a left-wing one. As a result, we might expect a lot of policy change. The people have clearly signaled they want to change from the status quo. Let's see what happens. We'll continue to trace the path of all the original status quos that converged to the first legislature's gridlock interval. Starting from the left, we can see that several policies stay in place. They don't move farther left, even though the median and president have both shifted leftward. And they don't shift because the filibuster pivot in the new legislature prevents that leftward movement. The remaining status quo policies are in Region 4, and therefore partially converge to the median, so we get some leftward movement. However, we still don't get full convergence to the median because of the filibuster pivot to the right. Even though the election between the first and second legislative sessions resulted in a quite dramatic leftward shift in pivots, the supermajoritarian requirement from the filibuster foreclosed large leftward shifts in policies. Empirically, we often see this in the US Congress and other legislatures that use supermajoritarian procedures. Even when majorities from one party replace those of another, we don't see many laws change. Let's suppose another election is held and a new legislature is seated. We've now returned to a right-wing government. In fact, this government is more right-wing than the first. both the median and veto pivots have shifted to the right. Let's see what happens. Again, we'll trace the path of the original status quos that have now converged to the second legislature's gridlock interval. All of the original status quos are now fully contained in the final legislature's gridlock interval, so it will pass no laws at all. The returning right-wing governing coalition can't move policies to the right at all on account of the left filibuster pivot and the path of status quos over the last two legislatures. The pivotal politics model is certainly a simplification of real politics. However, it helps explain some empirical patterns in real legislatures. For example, in the United States, even during unified government, when the same party controls the House, the Senate, and the presidency, policies often remain gridlocked, remain stuck. Second, when bills do pass through the U.S. lawmaking process, even in the current era of intense polarization, they tend to pass with large supermajorities. Third, it can help explain the honeymoon stage after a new governing coalition is seated. New governing coalitions often have success early on that quickly fades. In the language of pivotal politics, we can say the new gridlock interval shifts after an election, and if there are any policies no longer in that gridlock interval, the new coalition can change them. Once those status quos are exhausted, however, there is nothing politically feasible left to do. Last, it can help explain why incumbent parties and presidents often face declining popularity over time. As time goes on and fewer status quos are changeable, the public may get increasingly frustrated at gridlock in DC. This video provided an overview of the theory of pivotal politics, a theory more complex than simple majority rule that incorporates some real-life features of the US Congress. The next video will add an important step to the lawmaking process that has become much more common over the last century or so: presidential unilateral action through executive orders.